Okay, this assignment is not real good for video, but I've still got to do it. There's 3 parts to it, so you can't just, within the parts, if you want to go work on the sign, you can, but there's 3 parts. Here's part 1. This is the weirdest part. What you have, I can't put this picture on the computer. You have a shaft going into a hole. Now, we all know the hole's got to be wider for the shaft to fit into it, okay? Now, the shaft or the hole is called diameter A, the hole is called diameter B, okay? You have this table, you're going to type in the answers in the boxes that are blank, okay? Now this stuff at the top is very, very important, so make note of that. Okay, number 1, we have diameter A, diameter B. I wrote it down on paper so you could actually see what I'm doing, or you can't see what I'm typing in on the document. So diameter A has basic dimensions of 1.4580. This has a basic of 1.4610. So this is wider, so that has to be the hole and that has to be the shaft. Now, let's find the maximum of the shaft. Well, it says up here, diameter A, we add that to find the maximum, then we subtract that amount to find the minimum. It's that easy, okay? 1.4580, first I add 0.0010, 1.4590. Then find the minimum, I'm going to take 1.4580 minus 0.0030. I'm going to explain why I'm doing that here in a bit. Now, that's supposed to be the basic, but you have an allowance. You're allowed to go that much over and that much under. That's maximum. That's called tolerance. Okay, the diameter B, the hole. Now I add 0.0030. That's 1.464. And then I subtract 0.001. I'm just going to move the compass on my calculator to save time. Okay, now this is how you find the maximum clearance. Whatever's your hole, okay, you find the maximum of the hole, so the hole's right here. It's maximum of the hole, the highest maximum, basically. Just go with the highest maximum minus your lowest minimum, which is right there. Okay, so the maximum of the hole minus the minimum of the shaft, okay? So we just subtract them, you minus them. That tells you the clearance between the shaft and the hole. So it'd be 9 thousandths. Okay, now the minimum clearance. You take the minimum, okay, the highest minimum. So again, I'm going to write this here. Maximum clearance is always the high max minus the low min. High max. Minimum is the high, minimum clearance is taking the high minimum, okay, the higher minimum, which is here, and subtracting the higher the lower maximum, high min minus low max. So high max minus low min is our maximum clearance. The highest minimum, which is here, minus your lower of the maximum. So you subtract those. So 1.46 minus 1.4590. Okay, so that's 0.001. And you type those 6 things into those boxes. I know, you just type them in. Okay, really you don't need to write a lot down. You just take that. And then you add, put it there, that, minus, put it there, that, add, put it there, that, minus, put it there. Now you take your high max minus the low minimum here. You take your high minimum, the higher of the minimums minus the low maximums. Basically, you're never going to have negatives. If you have negatives, you're subtracting in the wrong order, okay? Here, write this down on a piece of paper, and that should help, okay? Maximum clearance is the high max minus the low min. Okay. Minimum clearance is taking the high min minus the lower of the two maximums. Okay, if you write that down and just observe it, you'll be fine. Okay. All right, now we're going to do 2, 3, 4, and 5. 0.9345 plus 0.0010. So it's 0.9355. And then you minus, but you're going to minus 0.0030. 0.9315. Okay, then I go to my other one. This would be the whole, by the way. You don't need to label that, okay? Plus 0.0030, and that's 0.9395. Then we subtract 0.0010, 0.9355. Once again, the high max minus the lower minimum, so I minus those. Okay. 0.9315 minus 0.9395 minus 0.9315, I get 0.008. Okay, now the minimum clearance, again, the higher minimum minus the lower maximum, but that's 0, okay? If I subtract this minus this, that's 0. So the minimum clearance, it would just, you put 0. Okay. 2.1053 plus 0.0010, 2.1063. Then I minus 3 thousandths, or 30 ten-thousandths, it means the same thing. 2.1023. Okay, diameter B. You got to find these 4 things before you go over here. Okay, you take 2.1078 and add 0.0030, 2.1108. And now we minus 0.001. 2.1068. Okay, compare the maximums. This is the higher. What's the lowest minimum we have right here? Okay. So 2.1108 minus 2.1023, 0.0085. Okay, then I take my higher minimum. The higher minimum is still bigger than the lower maximum. Okay, it's just not going to be as wide of a clearance. 5 ten-thousandths, 0.0005. Obviously, the maximum clearance should be higher than the minimum clearance. Okay, 0.4941. Plus 0.0010, 0.4951, minus 0.4911. Okay. All right, 0.4970. I add 0.0030, 0.5. Then I minus 0.0010, 0.496. Okay, higher maximums here. The lower minimum 449916. So that's your lower. Okay. So 0.5 minus 0.4911, 0.0089. And I take the higher minimum and subtract the lower maximum. 0.0009. That's bigger than that, 0.00080, so that's still higher. I know I did that one right, okay. Last one, 0.996 plus 0.0010, 0.997. These are maximum. And I subtract 0.0030, 0.993. $1.007 plus 0.0030, 1.01, 1.007 minus 1.006. Okay, the higher the maximums is here, the lowest minimums here, so the difference in that, I think it's 8 thousandths. Nope, I'm way off. Okay, 0.017. Then you go with your your higher minimum. Okay, high minimum minus the lower maximum. 0.009. Once again, that's a bigger clearance than that. 0.010. Okay. That's this. Now on your assignment, this time this would be the hole, this would be the shaft, okay? Doesn't really matter, you don't need to put that in. Diameter A, you add 0.02, 20.75, and then you minus 0.02, 20.71, okay? You minus 20.7, minus, and then here, diameter B, you do the same thing actually on your assignment. You're going to add, you get 20.7, then you minus 0.02 and get that. So the higher maximums here, the lowest, so subtract those now would give you your maximum. And then you look at the higher minimum and subtract the lower maximum, 0.01. Okay, that's what you do on that part. Now, let's go to part 2. Okay, so that's that. You fill in any blank box. This is the same thing. Refer to not the same thing, sorry. You fill in the box that's blank. Each problem has one blank box. Okay. Refer to the table to determine the tolerance, the maximum limit, or the maximum lower limit. Now you might want to write these down on the same piece of paper. Okay, if you don't know the tolerance is what you just found. It's the max minus the min. It's pretty easy to find. Okay. If you're looking for the maximum, that means you have to get to the highest number you would add. Okay. If you're looking for a minimum, you would have to subtract. Okay. Okay, so this one, we're looking for the tolerance. We know the maximum's this much. And the minimum, or sorry, I'm on the one. 5 here. Okay. So the tolerance, the maximum's here, the minimum's here. Tolerance, you just take the max minus the min. Okay. So we take 5 and 7 over 16 and subtract 5 and 13 over 32. You can Google that mixed number calculator if you want. So that'd be 1 over 32 is your tolerance. Okay. Okay, now they give us the tolerance, they give us the maximum, we have to find the minimum. Well, the minimum's got to be lower than the maximum, so you're not going to add, okay, you're going to subtract. That's going to be 16.74. Okay, this is pretty easy. Okay, you find the tolerance, you subtract again. Okay, you take the maximum minus, it's just a different, tolerance is a difference between the maximum and the minimum. Like, idiot can get it punched in, right? 0.3 thousandths. Okay, tolerance again, subtract again, 50.7. And again, type it in the box on the assignment. 0.9. Okay. Okay, now you're finding the maximum this time. Now to find the maximum, you got to make the number higher. That's your minimum. The maximum's got to be higher than the minimum, so that would be adding. To find the maximum, you add. Not hard to see why. Okay. Plus 0.04. Because to make the maximum higher than minimum, you take your minimum and add the tolerance. 258.07. Okay, and to find the maximum, again, you add 12.731 plus your tolerance, 12.737. So again, tolerance max minus min. The maximum, you have to add the minimum to the tolerance. Minimum, you subtract the tolerance from the maximum. Okay, and then the last part, part 3. Okay, I had to make a thing for this because I didn't have a sheet for it. I have on this sheet exactly what the table, and this is pretty easy. What you have is the actual, what the true values is and the measured value. Well, you're off a little bit in your measurement. You have to calculate the error of your measurement, and there's 3 things you do. Okay. First thing you do for the absolute error, you just subtract these. You're trying to find out how much that's off. Okay, you just take the highest wherever it's at, minus the lowest. That's your absolute error. Easy enough, okay? Okay, the relative error. To find the relative error, now this is the hardest part, I would say. You are going to divide, you have to do a division. You're going to take your absolute error, and you're always going to divide by what the actual value is, okay? Always by the actual value, 3.872. Okay, and round to 1 significant digit, okay? Okay, so that's 1, 2, these aren't significant, but that 5 is, so it's 0.005. Just do 1 significant digit. That's relative error. Now to find the percent error, it's easy. You just move the decimal twice forward. Okay, so it's 0.5%. You just fill those in the table. Okay, next one. Take the highest minus the lowest. 12. It doesn't matter if the measured value is higher or if the actual value is higher. Just take the highest minus the lowest. Just find the difference. So 0.2. Now the relative error, you take that 0.2 and you're always dividing by what the actual measurement is, 12.7. Just 1 significant digit. Okay, so 1 is my first significant digit, but it would round to 2, 0.02 again. Trace the decimal twice forward, and it's 2% error. Okay. Okay, next one, subtract highest minus lowest, 24.00 minus 23.86. Just put 0.14. Okay, relative error, take your 0.14 and divide by, again, the actual value. Just round 1 significant digit. 0.14 divided by 23.86. 0.006. And to find the percent error, 0.06. Sorry, don't have enough zeros. Trace it twice forward, that's 0.6%. Okay, now this is actually easy to do on a calculator, okay? 105, all three steps, okay? 3. Then I take the 3 divided by 105. That would be 0.03. Twice 4 would be 3%, okay? It goes that quick. 1.015 minus 1.005, 0.001. Now you're going to divide that. 0.001 by the 1.005. Always divide by the actual, what the actual measurement is. Okay, one significant digit, that'd be 0.000. There's my first significant digit, but it would go up to but actually here's how that would go. You would have to come before it and round that one to a that goes to a 0 and that goes to a 1. Okay, so 0.001 twice forward 0.1%. Okay, 183.2 minus 1827.6, not that way. 1830.2 minus 1827.6, 2.6. Okay, then I take the 2.6 and I divide by 1827.6. One significant digit, 0.001. It'd be 0.1% as your error. Okay.